Today I will discuss radiocarbon dating with you.
It is no secret that in dating, timing is everything. When studying the past, whether finding coins, bones, or pathogens buried in a mound, the question of when they are from makes the difference between a meaningful or a misleading discovery. Dating is so crucial that Willard Libby of the University of Chicago won the Nobel Prize in Chemistry in 1960 for developing radiocarbon dating that allows dating organic remains. Radiocarbon dating is based on the observation that living beings exchange 14C with their biosphere while alive and cease to do so when dead. At that point, their 14C atoms decay into 14N with a half-life of 5,700 years, whereas their 12C concentration remains constant. Thereby, assuming that the initial ratio of carbon isotopes in the biosphere remained constant over time, measuring the 14C to 12C ratio allows inferring the tissue's age, at least in theory. In practicality, 14C has many shortcomings due to the changes in the 14C-12C ratio over time, low organic material or radiocarbon levels that bias dating, and contamination with modern samples. The variation between labs alone can be up to 1,000 years. It is like dating King Saul to Jesus' time or dating the current Prince of Wales to the period of Owain Gwynedd.
The alternative to radiocarbon dating is using archaeological artifacts found alongside the tissues, which works very well if we find a skeleton carrying a coin minted by Julius Caesar, but far worse if we find one without any cultural identifiers, as is often the case. Non-human bones, for example, are nearly impossible to date archaeologically. Since archaeological dating is very subjective, the misconceptions are great. The Dara-i-Kher cave in Afghanistan, for example, initially assumed to be from the Paleolithic, 30,000 years before the present, was later radiocarbon dated to the Neolithic, some 25,000 years later. Paleogenomics, the science of reconstructing and studying the DNA of ancient organisms, positioned itself as the authority on understanding not only the genetics, but also the history of ancient people, from mummies to Paleo-Indians. However, only about half of these people were radiocarbon dated.
None of the Scandinavian Vikings that were sequenced could be radiocarbon dated, which makes it impossible to study their personal history. When it comes to dating, one of the most controversial sites is Brandýsek, in the Czech Republic, where multiple individuals were found. Based on both radiocarbon and archaeological context, the site was dated to the Bell Beaker period. However, one of the skeletons was radiocarbon dated to around 5,500 years before present. Given the problems with radiocarbon dating and that only 2 out of a dozen other individuals were radiocarbon dated, it was difficult to decide whether this was a bias or a factual finding. Obviously, this has implications for the historicity of the site. We developed a temporal population structure tool and used it to date 5,000 ancient and modern genomes, including nearly 500 families, the ultimate challenge of any dating algorithm. In dating families, it is not only critical to predict the correct age of ancient family members but also to place all family members at the same time, not hundreds of years apart. TPS dated relatives to within 17 years of each other more accurately than alternative dating methods. While TPS performed well, note that it is not a substitution for radiocarbon dating due to its need for training data to predict ages. In other words, TPS can be used for dating the remains of humans and farm animals, for which extensive ancient genomic data are available. It could even provide much-needed information for precisely dating ancient Egyptian mummies. However, those who intend to travel to the past to meet an ancient elephant or a monkey, you are on your own.
If you like our channel, please like, comment and share. Thank you.